Hello.
Yes, good evening.
So, any doubt from the last class?
No, sir.
Okay, sir. Just wait a few minutes. Let me see.
Yes, Shakir. Any doubt? Tell me the last topic which we had done in last class.
Sir, we were driving the equation of specific heat constant.
Okay. I'm giving you one more problem related to some electrical term. For any of the electrical term, we must have to know first dimension formula of charge. For defining this particular charge, the formula is current is equals to rate of flow of charge through any conductor. Current is any fundamental quantity and time is fundamental quantity. So first rearrange them. So Q is equals to current into time. We have dimensional formula for current as capital A and dimensional formula for time as capital D. So the dimensional formula for charge would be A into T. On the basis of this, you can easily calculate the rest of the whole term which is based on electrical parameter. Suppose voltage, EMF, potential difference. These all three means the same term. It is represented by V, which is equals to work done to move any charge from one point to another. So it will be work done per unit charge. We know the dimension formula of work done, and we have dimension formula for charge from this term. Just put them and try to simplify it. Dimension formula of work done is ml square t raised to the power -2.
Sir, what about charge? Is it electric charge?
Yeah,
Okay.
we have just derived this. Charge is equals to A into T.
Yes. Should send you, yeah?
Yes.
Send the answer to you? Should I send the answer to you to MZ in chat?
Yeah.
Okay.
Kezia, any doubt from the last class? Do you have any doubt from the last class?
No, sir.
Okay.
But I will be leaving the class at 5 o'clock.
Why so?
I have an exam.
Okay.
Thanks.
Sir, I sent.
Good. The rest of you, please send your answer. Aisha, Mariam.
Right.
Okay.
So could you show this one?
Which one?
Can you show?
How to solve this?
Yes, ML.
Suppose for this particular work done, we have dimension formula as ml squared t to the power minus 2. So just write there dimension, divide by charge, which we have A into T. So on simplifying, there is only one m in numerator. There is L squared. We have time t raised to the power 1 in denominator. So on division, power gets subtracted. So it would
Minus
be
3.
minus 2 minus 1. So it would be
Minus
t raised to the power minus 3. And last, we have A in denominator. So on bringing from the numerator, it will become minus 1. Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Let's go to the power of
Fair.
correct, sir.
Okay, so we have this particular dimension. On the basis of this, we have three different properties of a substance. First is resistance, denoted by R. Second is capacitance, denoted by C. And third one is inductance, denoted by L, or you can call it as self-inductance. What do they actually mean? Resistance is nothing but the property of a substance to oppose the flow of charge through it. So it is any opposition property of substance. Capacitance, similarly, the ability of a substance to store charge in the form of electrical energy. Likewise, we have battery, which stores energy in the form of chemical. And this particular device, which is called capacitor, stores energy in the form of electrical charge. So the tendency of storing charge is defined in terms of capacitance. And the last part, which is inductance, the property of coil to oppose variable current, likewise resistance, which has ability to oppose charge flowing through it. So these are just the tendency of different substances. We have to deal with their dimensions only. So for the dimension of resistance, heat energy is equals to I square R into T. Similarly, for capacitance, energy is equals to half Q square divided by C. And for inductance, energy is equals to half times L I square. So here we have heat, H, I is current, R is resistance, and T is time. E is energy, work done, energy, heat, all resembling the same dimension formula. So just put the dimension and try to simplify the rest of the part. From this part equation, try to solve for R. From the second equation, try to solve for C, and from third equation, try to solve for L.
So for resistance, if we write R is equal to V by I, what we
Yeah,
did
you may.
earlier.
You may say V is equals to I into R. So R is equals to voltage divided by current. We have dimension formula for voltage as we have just derived this. And we have dimension formula for current, which is just fundamental quantity measured in terms of ampere.
Sir, I is current, yeah, and
Yeah.
V
You
is
either can use this particular formula or this formula.
or sir, what about V? It's I think it's a potential
V is
difference.
voltage or potential difference.
Oh yes, yes, okay, fine.
So you can either solve this particular term as Q is equals to C times V. V is voltage here.
So now I will send you resistance, okay?
Okay, just 1 minute. Check the dimension of A, Shakirullah and Mariam. We have already A to the power -1 for voltage, and we have again A for this particular I.
Sir, I am sending. You check, okay? To MZ, yeah?
Yeah.
Okay. I have sent, sir.
Good. Good, Mariam.
Okay. I now send the next one, okay? Capacitance.
Okay.
Sir, what's Q,
Q
sir?
is just charge. We have
Okay,
already
charge,
derived
yeah.
this.
So for capacitance, we should find the dimension of C, yeah?
Yeah.
Okay.
Good, Ikram. You just write R is equals to, okay? Similarly, C is equals to. Ikra, check the exponential of L.
Okay, sir. Minus.
Good, Mariam. Now it's correct. Kezia in doubt while solving? Aisha? Send me your answer.
Sir, I have sent you the capacitance. Can you check, sir?
Just check the exponential of T and A. Okay, Shakib?
Sir, means I should try once.
Yeah.
Sir, if I want to find for dimension of C, so
Yeah.
it will be Q divided by E, yeah?
Q divided by V. If you are using this equation,
No, if I
if
want to find
you're
out
using
C,
this equation,
yes,
so
if
it
I
would
want,
be C is equals to Q squared divided by E. It has square.
it has square, yeah?
Yeah.
Square means, so I should open the square. Okay,
Just multiply the exponential by 2.
okay, I will do.
You can try to solve once more for L.
Okay, sir. Yes.
Aisha, are you solving? I'm unable to get your voice.
So now I have sent.
Now it's correct. Ikra, we have to solve for L. So keep this particular L to one side and bring this particular I to the other side. It will be in
So I thought it
denominator.
is 1/2. I thought it's 1/2.
He said, do you have any doubt?
Sir, for self-inductance, it will be L is equal to E divided by
I squared.
E divided by I square, yeah?
Yeah. Mariam, check the exponential of T for calculating L.
So now I have
Good
seen
sharing.
this is for self-inductance. Is this correct?
Good,
Answer?
Ikra. Yeah. Now it's correct.
Okay.
Hello, sir. Can you hear me?
Yeah.
Sir, did you got my answers?
No. Just send your answer to MZ.
Okay. I have sent it.
Mariam, here we have I square. Check the exponential of t as well. Good, Aisha. Send me your second answer, Aisha.
Yes, sir. I'm typing.
Okay. Good. Just see the last part, Mariam. Here we have L. 1 by 2 is just any constant, so just remove it. So L would be equals to energy divided by I square. For energy, dimension formula is ml squared t raised to the power minus 2 divided by I, which is current. So it would be A squared. On bringing it to the numerator, it will become ml squared t raised to the power minus 2 and A raised to the power minus 2. Okay, Mariam?
Yes, sir.
Now it's correct. Good, Aisha. So we have done this all three segments. The next part is we have just finished all the dimension formula related term. The next topic in this particular dimension analysis is principle of homogeneity. What this particular homo means, we have already know about homogeneous mixture, homologous series, homologous organ, and so on. So homo means same or similar type. For this, I'm defining you one more term. Like when you have started learning algebra in mathematics, we have just defined like term and unlike term. Suppose if you have 2x squared minus 5x plus x squared and plus 2x. And you have to just simplify this particular term or reduce this particular expression. How do you start? Just see this particular term and this particular term having same exponential of variable. So we can call them as like term. So we have 2 as coefficient here and 1 as coefficient here. On adding, it will become 3 times of x squared. Similarly, for this part and this part, both containing same variable x and x, so we can also call them as like term. So on solving, we have -5 and +2, so it will be
minus
3x with negative sign.
yes.
So we have just defined this particular expression or reduced this particular expression on the basis of whether it containing like term or unlike term. Similarly, in physics, while operating any of the two quantities, we must first define whether the two quantities contain same dimension formula or different dimension formula. So principle of homogeneity tells you about if two physical quantities can be added, subtracted, or equated only if they contain same dimension formula. Otherwise, different dimension formula term could not be added, subtracted, or equated. Is it clear to everyone?
Yes, sir.
So we
Sir.
can state this particular principle of homogeneity as two physical quantity can be added, subtracted, or equated only if they have same dimensional formula. Suppose A plus B, A minus B, or A is equals to B. In either of these three operations, it would be possible only if A and B having same dimension. Any doubt? Aisha?
No, sir.
Okay. So we have just defined principle of homogeneity. On the basis of this, I'm giving you one problem and trying to define you how to solve that. Suppose if you have P plus A divided by V square, V minus B is equals to some C. We have P as pressure in this expression, V as volume. We have to calculate, find dimension of A, B, and C. So just see how to approach this particular problem. In the first bracket, we have two different terms. First one is P, and there is plus sign in between A over V squared. So according to this particular first expression, what we conclude about this about their dimension, if two physical quantities are related by any plus sign or minus sign or equal to sign, it means they would have same dimension formula. So on the basis of this, we can simply compare these two terms for having equal dimension. So P would be nothing but A divided by V squared. We know the dimension formula of pressure and we know the dimension formula of volume. Just put them and try to solve for A. Is it clear to everyone?
So can you explain again?
Okay, just 1 minute. In this expression, in the first bracket, we have pressure plus A divided by V squared. As we have already defined this particular expression for the principle of homogeneity, if two physical quantities are related by plus sign, minus sign, or is equals to sign, this particular relation would be possible only if they both would contain same dimension. Is it clear?
Yes, sir.
So on the
Yes,
basis
sir.
of this, we can simply define it as if P and A over V square are related by any plus sign, so we can say their dimension would be equal. So the dimension formula of pressure and dimension formula of A over V square must be equal. We all know dimension formula of pressure and we all know dimension formula of volume. Just put them and try to simplify for A. Shakir, any doubt?
No, sir, but we have to find A, yeah, in this
Yeah.
in here. First of all, we have to find A, then we want to make it equalize.
On this particular, we have dimension formula of P, we have dimension formula for volume. Just bring this particular volume to the other side and
Yes,
try
yes,
to
yes.
solve for A.
Okay, okay.
Just write it down and try to solve for A.
Yes, I will do not. I will try.
Okay.
Sir, I have sent you the term A. Dimension A.
Just see, we have squared of volume here.
Sir, sorry, did I make mistake? Sorry.
So should we, so everything we should make double, I mean, 1 into 2.
For which part? We have only volume squared. So the dimension of volume would be squared each term, or you can simply multiply each exponential by 2. Okay. As we have rule of exponential, it tells you if there is x to the power m and to the power n,
It will be M
so
plus.
it will be m
M plus.
into n.
Yes, sorry, M into N. Sir, I have sent again. Can you check?
Good, now it's correct.
Okay. Now I should do for B.
No, I will tell you.
Okay.
On comparing, it would be A is equals to P times V squared. We have dimensional formula of pressure as ml to the power -1 e raised to the power -2.
Minus 2.
And for volume, it is L to the
L
power
cube.
cube and squared over it. So power to the power becomes multiplied. So it would be L to the power 6. And we have already L to the power -1 here. So on combination, it will be L to the power 5 t raised to the power -2. Is it clear to everyone?
Yes, sir.
Yes.
Ikra?
Yes, sir.
Okay. So the next part, we have V minus V. So what we conclude about their dimension from this expression? From this relation, if two quantities are related by subtraction sign, it means they would have same dimension. So we can say B is equals to nothing but V. And we have dimension formula for volume as L cube. So dimensional formula of B would be nothing but L cube. Okay.
So now we have to find the C, yeah?
Just wait, I will define you how to solve for C. Have you already done this, Mariam,
Yes, yes.
Yes, sir.
Aisha?
Yes, sir.
Yes,
Okay,
sir.
just the next part, how to define this particular C. For this, I'm giving you one relation. Suppose if you have to add 3x plus 4x, and if you have to subtract 5x and 5x. Tell me the first answer.
7x.
Good. And for the second?
0.
0.
X. 0. X.
While adding or subtracting, only the coefficient changes, but variable remains the same. Likewise, if we have 3x and we have 4x, it would be just 3 plus 4, 7, and x being remains the same.
Yes.
Similarly, while subtracting, 5 minus 5 would become 0, and coefficient with variable it remains same, x. As 0 multiplied with any of the number equals to 0, so the total answer would be 0. Okay.
Yes.
But now if we are solving for dimension, let's say we have L plus L. What would be? L plus L would be nothing but 2L,
2L. Yeah.
and 2 is nothing but any numerical value, which we have already know about. It is dimensionless constant part. So we can neglect this
Yes.
particular 2. So what we're left with? Just L. Is it clear?
Yes, sir. You have thought.
Yes, sir.
That
Similarly, if you
numerical
have to
values, we will-
subtract L minus L, it would be nothing but 0 times of L. And 0 is any numerical value, which is dimensionless constant part. So we can
So
simply remove it, and
Okay.
we're left with
It will
just
be L,
nothing
yeah?
but, yeah. So what we conclude from this expression, L plus L would be L itself. Similarly, L minus L would be L itself. This particular term is valid only for dimension. Okay.
Okay.
Mariam, any doubt?
No, sir.
So by using this, we have P plus A divided by V square. The second part is volume minus B is equals to sum C. So for the first part, we have two different parts. First is pressure, and second one is A divided by V square. So what we conclude about their dimension, if two physical quantities are added, it means these two terms would have same dimension. So if first term is your pressure, then the second term must be pressure. Is it clear?
So can you say again, sorry?
If two physical quantities are related by plus sign, so it means according to principle of homogeneity, their dimension would be equal, or they would represent the same dimension formula or same physical quantity. So if first part is your pressure, then the next part of this particular combination would also define you nothing but pressure.
Yes, yes, okay. Right.
Now we have a plus sign in between it. So what we conclude about this particular relation, P
This will be
plus P would be nothing but
P.
good. Similarly, if you solve for the second part, we have first volume. So which quantity would be represented by this particular B?
It will be, sir, V.
Good. So it would be V and V itself. And
V
there is
minus-
negative sign in between it. So what would this particular operation would give you?
It will be V, sir. Simple V.
Good. And there is nothing but multiplicative sign in between it, and is equals to nothing but C. So this will be our final answer to calculate the dimension formula for C. We have dimension formula for pressure and we have dimension formula for volume. Just put them and simplify to find C.
Okay. Now I will show you.
Ikra, any doubt?
No, sir, I understood.
Good. Mariam?
Understood, sir.
Good.
Sir, I have sent.
Good. Mariam, here we have P, which is pressure, and V is just volume. P is pressure and V is volume. Just put the dimension and simplify. Just see, we have dimension formula of pressure as this part, and dimension from formula for volume is this part. Good, Mariam. Ikra, send me your answer. Aisha? Good. Aisha?
I am doing.
Okay. Just see, Aisha. We have P, which is pressure. So the dimension formula is nothing but ml to the power -1 and T raised to the power -2. For volume, dimension formula is LQ is equals to C. Here we have L raised to the power -1 and here we have L raised to the power 3. They are in multiplication, so power will be added. -1 plus 3 would becomes ml square T raised to the power -2 is equals to C. Okay, Aisha?
Yes, sir. I came to know where I did mistake. Thank you, sir.
Good. Okay, so we have just defined how to solve this particular term on the basis of principle of homogeneity. on giving you some more concept regarding this. Suppose if you have trigonometric function like sine x, cos x, tan x, or any of the term. Similarly, e raised to the power x and log of x. I'll define you this particular term log in your mathematical part or mathematical physics later. In this particular expression, we have this x, and this x. What these particular x would define you. For any of the trigonometric function, if x is related with it, it will define you nothing but angle. And we have already learned about it. Angle is any dimensionless variable quantity. Okay?
Yes, sir, because it gives
Yeah.
arc.
So angle is nothing but any dimensionless quantity. For any of the dimensionless term, we use m to the power 0, l to the power 0, or t to the power 0. As there is no dimension of mass, length, and time for this particular angle. So we already know about it. If the exponential of any term is 0, it would equals to nothing but 1. So if a quantity is dimensionless, just equate it to 1 and try to obtain the rest of the part which you have to calculate. Okay. Similarly, this particular x and this particular x would define you nothing but any number or pure number. So as we already know about it, number is any dimensionless constant part. So whether angle, which is related with trigonometric function, and whether number related with this particular exponential function or logarithmic function, these two would define you nothing but dimensionless quantity. So angle and this particular number would be dimensionless.
Means, sir, sorry, sin x means an ex and log x, they are dimensionless, yeah?
No, we are just defining the value x itself, x.
Okay.
Now, just see the whole value of the sine x. Sine of x, e raised to the power x, and log of x. This whole term. Suppose if you have to calculate sine of 30 degree, it would be half or 1 upon t. So sine of 30 degree is equals to just half. What we can conclude about this particular term? It is nothing but any constant number, and which would be dimensionless constant part. Similarly, e raised to the power x, we have already know about it. E is equals to 2.72. If e raised to the power 1, it would be 2.72. If e raised to the power 2, it would be 2.72 and squared of it, and so on. So this particular whole term, and this particular whole term, in any of this particular expression, it will define you nothing but any number, which is again a dimensionless quantity. Is it clear?
Yes, sir.
Yes, sir.
So we have just
Clear.
defined whether their angle or whether the whole part, both part would be nothing but dimensionless. So just equate that particular dimension to 1 and try to obtain the rest of the part in that particular expression. Okay, I'm giving you one problem related to this. So from this we can define whether angle or their argument. This whole term sine of x is called argument of that particular x. Okay,
Yeah.
and x is called angle. So whether angle or their argument must be dimensionless. So for any of the dimensionless quantity, just equate it to 1 to find the variable unknown part. First of all, write it down. I'm giving one example related to this.
Done, sir.
Aisha, have you written?
Yes, sir.
Done, sir.
Shakir, done?
Yes, sir. Sir, wait, sir. Sir, means, sir, if sin x, if the x, its value is given like sin 30, so
Yeah.
so it will also be dimensionless, yeah?
Yeah.
Because wherever the numerical value is there, so it will be dimensionless, yes?
Yeah.
Okay, sir.
Suppose if you have a question, if y is equals to a times sine b of x plus c of b. We have x and y in this expression as displacement. T is time. We have to calculate, find dimension of A, B, and C. Just see how to solve this particular problem. Just see sine of this particular whole part, whether this particular b times of x and whether this particular c times of d. These two terms would define you nothing but angle related to that particular sine. Okay, so this would be your angle and this would be your angle. And we already know about it, angle is dimensionless term. So for any of the term which is dimensionless, just equate it to 1.
1, yeah. Sir, what
We
about
have,
the, sorry, sir, what about the bx? It is, so it has angle, so it will be is equal to 1. What about ct? How it's
it would be
dimensionless?
again equals to 1, and it is also representing angle itself. Okay,
Because maybe someone will knew that t is time.
suppose if you have sine of 45 degree, you can write it as sine of 60 degree minus 15 degree. Okay, or you can write it as sine of 30 degree plus 15 degree. Okay,
Okay.
so if two quantities are added, it means they would behave like similar term. So if first term is your angle, the next term must be your angle according to principle of homogeneity. Okay.
So means bx plus ct, they are upon
Both.
the sign, yeah?
Yeah.
They will give degree.
Yeah.
Number. So okay, sir. Thank you.
Just see the first expression. We have bx is equals to 1. X is nothing but displacement. So just move this particular displacement to other side. It will be b is equals to 1 divided by x. Put the dimension of x, which is equals to length. If you bring this into numerator, it will become L raised to the power minus 1. So we have just defined the dimensional formula of B. Is it clear?
Yes, sir.
Similarly, try to find the dimension formula of C as well.
Okay.
Good, man.
Absent C.
Good. Ikra, Aisha, just send your answer. Good, Ikra. Aisha, Aisha, done. Aisha, so we have done this particular B and C. C is equals to nothing but 1 upon T. T is time, so the dimension would be capital T. If we bring this particular term to the numerator, it will become T raised to the power minus T.
Minus 1, yes.
Okay. So we have just defined the dimension formula of B and C using the principle of homogeneity. Now, just see this whole part. Sine of that particular angle. What would be the dimension formula of this particular whole segment, this whole term?
Sir, is it will be, sir, sine into h to the power of minus 1 plus t to the power of t to the power of minus 1.
This whole term would represent you nothing but any number.
Dimensionless, it will be
So it
1.
would be nothing but dimensionless. So just remove it. We have to calculate the dimensional formula for A. And rest of the part would be y is equals to nothing but A. Y here is displacement. So A would be nothing but L. Okay. Is it clear
Yes,
to
sir.
everyone?
Can you
Yes,
explain again? I was having some network issues.
Okay. Which part? C.
Sir, I want that C1. C1
Okay.
I know, sir. That B one I want to know.
B or A?
B, sir.
B.
Yeah.
As sine is related with any of the term which is written here would be nothing but angle. And angle, as we have already defined, is dimensionless constant part or dimensionless variable part. So if any term which is dimensionless, so just put or equate that particular term equal to nothing but 1. Dimensionless would be m raised to the power 0, t raised to the power 0, or l raised to the power 0, like this. So if any number containing exponential to be 0, it would be 1.
So,
So
sir,
we have just, on the base of this, we have put bx as it is defining in this particular expression as angle. So equate it to 1. We have dimension formula for x. From this, we can easily solve for b. Okay, Aisha?
Yes, sir. Thank you, sir.
Now just see the next part. Sine of this particular whole angle. would define you nothing but any numerical part, and any numerical value is dimensionless constant part. So this whole term would represent you dimensionless quantity. So what we're left with? Y and A, and there is equals to sign in between them. So it would be Y is equals to A, Y is displacement here, and which would be just capital L. Is it clear to everyone?
Yes, sir.
That's clear.
Have you
So,
written,
sir,
Aisha?
So that A part I'm writing.
Okay.
That's
Ikra done?
Yes, sir. Done.
Okay. I'm giving you one more problem. If P is equals to alpha divided by beta log alpha times x divided by E. In this expression, P is nothing but pressure, x is nothing but displacement, and E is nothing but energy. Find dimension of alpha and beta. Try to solve.
okay. So, so first of all, we should have, start from the bracket, yeah?
Yeah.
Okay.
First, try to solve for this part. We have dimension formula for x and dimension formula for E. Try to obtain dimension formula for alpha.
So can you show how to solve it?
No, sir, wait, I'm trying.
Okay, no problem. I just see the last concept, this part. Already defined log of any term x. So x would represent you nothing but any number. Number is any dimensionless. So on the basis of this property, just equate this whole part or take this whole part to be dimensionless. So equate it to 1 and try to obtain for alpha. Okay.
Okay, sir.
Sir, I have found the answer for the bracket only. Should I send it?
Yeah. Oh, Shakir, just try to solve once again.
Okay, sir.
Kezia, we have just defined principle of homogeneity. It tells you if two physical quantity would be added, subtracted, or equated only if they would contain same dimension. So if there is written a plus b, a minus b, or a is equals to b, all of three expression would be possible only if a and b contain the same dimension. Okay.
Okay, sir.
On the basis of this, I have given a question. Suppose p plus a over v square bracket b minus b is equals to c. So here p and a over v square are related with some plus sign. So according to this particular rule of principle of homogeneity, if two quantities are related with plus sign, it means that two would contain the same dimension. So just equate them on the basis of their dimension and try to solve the rest part, which is unvariable in this particular expression. Okay.
Okay, sir. Okay.
Similarly, we have done for this particular second part. V and B are related with negative subtraction. So according to principle of homogeneity, their dimension would be equal. So we have just equate them. So dimension formula of B would be L cubed. So this we have just defined principle of homogeneity. You can take a screenshot. Done. Asia.
Yes, sir. Done.
In the second part, we have to solve for this particular C. We have derived a relation if two quantities are added, suppose L plus L, it will give you nothing but 2 times of L. 2 is nothing but any number which can be neglected on the basis of dimension. So we can say L plus L would be nothing but L. Similarly, L minus L would be nothing but L. On the basis of this relation, we can define P plus A over V squared. If they are related with some plus sign, it means the dimension of these two terms would be equal. So this first term is representing pressure, then the next part must be representing the pressure on the basis of principle of homogeneity. Now we have P plus P. If two physical quantities are added, so we can take them as a single part. So we can say P plus P is equals to P itself, as we have already defined L plus L is equals to L itself. Similarly, the next expression is volume minus P. So it would represent volume itself. So we can say volume minus volume. So it would be equals to volume itself. Now we're left with nothing but P into V is equals to C. We have dimension formula for pressure and we have dimension formula for volume. Just put them and try to solve for C. Okay.
Okay, sir.
Sorry, sir.
can-
Can you just explain once again? Sir? Sorry.
Okay, just 1 minute. Okay. Yes, Shakir, ask a question.
This one, sir.
Yes. What about this one?
Sir, I didn't get the answer.
So can you solve this?
Sir, listen. I will just say you my way of answer. Okay.
Okay. Just
So
solve.
okay.
I'm solving for the rest of them. Okay. Mariam, have you solved?
No, sir.
Kezia, just see. We have described these three expressions. Whether any trigonometric function is related with x, x would represent angle. Similarly, exponential function to the power x and logarithmic function to the base x. In these three conditions, x would represent any dimensionless part. And for any of the dimensionless part, for the comparison of their dimension, put it equals to 1. So this particular expression, log of some particular expression like this. So log is defined for this particular term to be any number. So for any number, x alpha upon e would represent you nothing but any dimensionless quantity. And for any of the dimensionless quantity, just equate it to 1. Now we have to calculate alpha from this expression. So alpha is equals to, bring this e to the other side. It is already in denominator here. So it will be in numerator, and x is in numerator. So on bringing to the other side, it will be in denominator. Now put the dimensions. Dimension formula for energy is ml squared t raised to the power minus 2. Similarly, dimension formula for x, which is length or displacement. Now we have L to the power 2 in numerator and L to the power 1 in denominator. So they are in division. So the power would subtract it. So we're left with L raised to the power 1 and T raised to the power minus 2. Okay, Kra?
Yes, sir. Now correct.
Yes, sir.
You know,
Yes, thank you.
because you told in log if there is x, you thought that it will give dimensionless, yeah.
The whole term, which is representing in this particular log.
Yes, so I thought that the alpha will be also 1 because it's dimensionless with the x. That's all.
Okay, okay. Now,
That's
this whole term would define you nothing but any number. And number itself is a dimensionless part. So just neglect this particular whole. So what we're left with? P is equals to alpha divided by beta. We have dimension formula for P, which is pressure, and we have already solved dimension formula for alpha from this expression. So just put them and try to solve for beta.
okay.
So beta is equals to alpha divided by pressure. Try to solve. Kezia, is it clear to you?
Yes, sir.
Okay.
Sir, I have sent my answer. I have sent my answer.
Good. Good, Mariam. Good, Aisha. Ikra, try again. For pressure, dimension formula would be m L raised to the power minus 1 and T raised to the power minus 2. And we have already solved for alpha. So put the value of alpha to be this and pressure to be this. just see alpha is equals to n L T raised to the power minus 2 divided by pressure, which is equals to m L to the power minus 1 and T raised to the power minus 2. Just see the exponential of m and n, whether these two would cancel out or not.
Yes.
So what will left with m raised to the power 0.
Yeah.
Similarly for L, we have 1 in the numerator and minus 1 in the denominator. So on solving them, it will become L raised to the power 2. And similarly for T raised to the power minus 2 and T raised to the power minus 2. So it would be T raised to the power 0. Okay.
Yes, sir.
Yes, sir.
Kezia, is it clear?
Yes, it is.
So we have just defined principle of homogeneity and solved problems like this. I'm giving you one more problem to solve. Have you all written?
Yes, sir. I'm there.
Yes, sir.
If force is equals to A divided by X plus B divided by V. Here, F is force, X is displacement, and V is velocity. Try to find dimension of A and B. Giving some hint how to approach this problem. We have first part A over X and second part B over V. And there is plus sign in between them. So the method of principle of homogeneity tells you if two quantities are related by plus minus, so their dimension would be equal. So if you equate A divided by X is equals to B divided by V. In this particular equation, we have two different variables. First one is A and second one is B. So you can't find two different variables from single equation. So just leave this particular relation aside. Next part is F is equals to this part and this part. So again, principle of homogeneity tells you if a quantity is equals to some different term, it means this particular quantity would have same dimension to this. And similarly, this quantity would have same dimension to this part as well. So equate F to A over X and again F to B over V. Now see this particular equation. We have dimension formula for force. We have dimension formula for X, which is displacement. Try to solve for A. Similarly, from this equation, try to solve for B. Okay?
Okay, sir.
Mariam, just check your
Sir,
answer once
I
again.
have my answer. Can I check? Can I send A and B?
Yes, Shakir?
I will send you the answers A and B.
Okay.
I
Good,
have sent correct both of them A
good,
and B.
good, good. Ikra, there is some mistake in your answer.
Okay, sir.
Here, just see, in this first equation, we have to calculate A. So what we can proceed with, just bring this particular x to the other side. Since it is in denominator in this side, so on bringing it to the other side, it will move to the numerator. So it will become f times of x is equals to A. Is it clear?
Yes, sir.
And we have already known the dimension formula for force and dimension formula for length. Just put them and try to simplify. Similarly, on solving this particular part, here we have velocity in denominator. On bringing to the other side, it will move to the numerator. So B would be equals to F into V. F is force and V is velocity. Dimension formula for force is mLt raised to the power minus 2. Dimension formula for velocity is Lt to the power minus 1. Now it's correct, Ikra. And x is nothing but length. Aisha, have you solved?
No, sir, I'm doing.
Okay. Ikra, just check the exponential for L, for B. Mariam, check the exponential for T. Kezia, are you solving?
Yes, sir.
Okay. Check the exponential for L. Pra. Good, Aisha. Good. Kezia. No. Just see. Good, Mariam. F is force, so it would be ml t raised to the power minus 2, and x is nothing but length. So on solving L and L, it will becomes L square t raised to the power minus 2. For the next part, we have force, which is equals to ml t raised to the power minus 2, and V's velocity, which will be L t raised to the power minus 1. So L and L on adding, it will
It will be
become
2, sir. Yeah, I
and t
understood
raised to the
everything.
power
Minus
minus.
3.
Good.
I did the mistake.
Anubhav, do you have class with me?
No, sir, actually, my chemistry extra class.
Okay, okay. Okay. So the next part is we have defined principle of homogeneity and all problems related with this particular part. The next part is find application of dimensional analysis. In this particular part, the first application is checking the correctness of equation. Or the next part, next we can say consistency of equation. What this particular term actually means. By the help of dimension analysis, we can easily analyze any of the physical equation, whether it is correct or not. Suppose if you have a relation like half mv square is equals to mgh. We have to confirm whether this particular equation or expression is correct on the basis of dimension or not. So first of all, try to solve for left hand side. LHS. We have half, which is numerical value. Next part is mass, having dimension capital N. Next part is velocity, so it would be L t raised to the power -1 and squared over it. So it will be N L squared t raised to the power -2. Is it clear?
Yes, sir.
Yes, sir.
So what is
Yes, sir.
Similarly, for right hand side, if I solve RHS, we have mass, capital M, G is gravity, or we can call it as acceleration to gravity. So it would have dimension as L raised to the power -2, and H is nothing but height, would represent nothing but length. So it would be M. L and L becomes L squared t raised to the power -2. So just compare the dimension of left hand side and right hand side, whether they are equal or not.
Yes, they're equal.
So we can conclude the dimension formula of left hand side and dimension formula of right hand side are equal.
Hence verify.
So we can confirm the correctness of this particular equation on the basis of dimension analysis. Is it clear to everyone?
Means that in this way
Yes.
we can check, yeah, it will be the same dimension when we want to check if they are same
Yeah.
dimension. In this way we can check.
Yeah.
Okay.
So if dimension of left hand side and right hand side are equal, then we'll confirm it is dimensionally correct. Okay, just write it down.
Done, sir.
Done, sir.
Yes, sir.
Okay, the next part is, Kezia, done?
Yes, sir.
If suppose there is written 3/2 mv square and there is written 5 times of mgh and there is equals to sign in between them, whether this equation would be equal on the basis of dimension or not, you may calculate and you'll find they two would be equal. But here we have coefficient 3/2 and here we have coefficient 5. But the actual formula of kinetic energy is equals to just half mv square. And the actual formula of potential energy is nothing but mgh. But here it is given 3/2 and here it is given just 5. So on the basis of dimension, we can't be able to define the coefficient of this particular expression. So on the basis of dimension, this expression would also define you to be correct. And similarly, this expression was also correct. So how would compare or confirm whether this equation is correct or whether this particular equation is correct? We can't be able to define it. So there is a limitation of this particular dimension analysis. So from this, we can conclude if an equation is dimensionally correct, it may or may not be correct. But if an equation is dimensionally incorrect, it will always be wrong. Okay. So
Yes,
I've just
sir.
defined you if an equation is dimensionally correct, it may or may not be correct. But if an equation is dimensionally incorrect, it will always be wrong. Is it clear to everyone?
Yes,
Yes,
sir.
sir.
Okay.
Sir, but sorry, how it can be if an equation is dimensionally correct, it may or may not be correct. How this is?
Suppose I have just defined you this particular expression in the first part. This expression on the basis of dimension, we have just concluded the left hand side and right hand side, they are equal. And we all know the kinetic energy, which is equals to half mv square, and potential energy equals to mgh. But in this particular expression, we have kinetic energy is written as 3 by 2 and potential energy is written 5 times mgh. And we all know kinetic energy equals to just half mv square. Okay, so on the
Okay.
base of dimension, you'd calculate this particular expression would also give you the same equation or same expression as this expression is dimensionally correct. But on the base of knowledge of this formula, we define this is not correct in actual way. Okay.
Okay.
So from this, we can conclude if an equation is dimensionally correct, it may or may not be correct. It depends upon the coefficient which is attached with that particular variable or that particular expression. Have you all written this last part?
Yes, sir.
Okay,
Yes, sir.
just write it down.
Sir, wait a minute.
And I'm giving one more problem. V is velocity, V is pressure, and rho is density. Velocity is nothing but Lt to the power -1. Pressure is nothing but ml to the power -1 ts to the power -2. And density is nothing but mass upon volume. Just put them and try to solve whether left hand side and right hand side are equal in dimension or not.
Okay, sir. Sir, they are not equal, yeah?
I think it would be.
Just sir, give me a few minutes.
whether they are equal or not.
Sir, wait, I'm trying, sir. Sorry.
Here we have square root. Square root on the base of exponential can be written as power half. Okay.
Okay.
You have to simplify only for right hand side. Just put the dimension formula for P, which is pressure, and dimension
sir.
formula for got the same answer to either side.
Yes, sir.
Good.
Sir, wait, I'm trying, sir.
Ikra, have you solved?
Sir, can you solve it and show me? Please.
Okay, just 1 minute. Kezia, have you solved?
I'm sorry, sir.
Ikra,
She left, I guess.
Sir, I have solved, yes. It's
Good.
it's equal, yeah.
Suppose V is equals to root under 3 times P over rho. We have to solve for right hand side. This particular square root in terms of exponential can be written as half. In numerator, we have pressure, which is equals to m to the power -1 and T raised to the power -2. Density is nothing but mass divided by volume. So m and m would cancel out. If we bring this particular term to the numerator, we have already -1, and this -3 on bringing to the numerator, it will become +3. So we're left with just L square and T raised to the power -2 and whole raised to the power half. If exponential and raised to the power exponential, the two would get multiplied. So it would be L square multiplied by half and T raised to the power -2 multiplied by half. So this term and this term would cancel out. This term and this term would cancel out. So we're left with LT to the power -1. So this is your right hand side, and we have already solved for left hand side. They are equal.
It is LT to the power of -1.
Okay, Aisha?
Yes, sir. Thank you, sir.
Ikra? And out? Kezia?
No, sir.
Okay, so we have just finished this particular whole topic. Just we'll stop here. I will continue in next class, that is conversion of unit from one system to another, SS system of unit, CJ system of unit, FPS, and so on. And the next third part, which is deducing relationship between different physical quantities.
Sorry, sir, next
Okay.
class, what we will take?
I think it would be on Thursday at the same time.
What the topic will be?
It will be application of dimension analysis and error analysis. Okay.
Application of dimension.